All right, hey, Michelle and not Allie, Maddie. I'm going to do just a little bit or a couple of examples on 6-3, but I'm going to use the 6-2 assignment number 8 to kind of like lead us into that. So yesterday in class, Michelle was here, Maddie was not. We did the right endpoints together where we found like the area of all these triangle-y things, whatever. And we found that that area using the right endpoints was 6.75, using the left endpoints was 7.75. So the actual area is going to be somewhere in between those two. This is a guesstimation, and doing the rectangle thing is kind of a pain in the butt, okay? But I'm going to show you now why we use antiderivatives to solve for area. So this example right here is the same example that we had up top here, but we're going to do it like the fast version using an antiderivative, okay? So if you need to draw this at the top of your paper, you can. That's fine, whatever. Or just write it down. But this is this function, and we are trying to find the area between just 0 and 2. So like just this chunk, so we're not including this guy over here. We're just going from 0 to 2, the top curve to the x-axis, just this area right here, okay? And we're not going to use triangles or rectangles to measure it. We're not going to like draw these guys in here, okay? We're just going to do the antiderivative, and we're going to find the exact area, okay? So the way that we will set this up, and you'll have to do this on your homework assignment. So when they have the graph drawn like this, you start by doing your integral, okay? So I'm going to write down here. I'm going to go down this left side or right side. You start by doing your integral, and then you'll have two numbers here and here, and the bottom number will be your left number, and your top number will be your right number. So like where you're starting and where you're ending at. And in that case, it's going to be 0 and 2. Do you see how that works? 0 to 2. We're going 0 to 2. And then we're doing the antiderivative of negative x squared plus x plus 4. Okay? Now, the only other thing that I will do is I'll put this guy in parentheses before I put the dx on the end of there, so that it doesn't look like you're just doing 4dx. So I'll put the parentheses on the end of there. And then we're going to evaluate this. Okay? Are we good so far? Like setting up, finding this area. So this is going to give us, as soon as we solve it, this will give us the area underneath of that curve from 0 to 2. Okay? So first thing we're going to do is just find the antiderivative. Okay? So starting with negative x squared, 1 over n plus 1. It'll be like negative 1/3 x cubed. Yeah? Okay, what about plus x? What will he become?
Half.
Half x squared plus
C.
What's the antiderivative of 4? Like what do you take the derivative of to get 4?
4x.
4x, right? 4x, okay? Now, we're not going to put plus c on because this is something called a definite integral. Definite integral, because we have things that we're going to plug in. We're going to eventually plug in 0 and 2, okay? So we're not going to put plus c on the end there. You'll see why going forward. Like I'll give you examples of why we don't need plus c, but I'll show you how this works. Okay, now I'm going to use some notation that's different than what you've seen before. I'm going to still put this guy in parentheses, but instead of putting that squiggly mark on the front, I'm going to put a little bar at the back. Okay, it's a straight up and down line. It kind of looks like the right half of a absolute value, and we put 0 here and 2 here. And this notation says I've taken the antiderivative, but I haven't plugged the numbers in yet. That's what that notation says. Okay, so when you're doing this and you're like losing track of your work, you know at this point I've taken the antiderivative, but I haven't plugged my numbers in yet. Okay, then all we do is we plug in the top number here. So this is plugging 2 into the equation, and this is plugging 0 into the equation. Okay, so we're gonna start by plugging 2 in, then we're gonna go and plug 0 in. So I'm gonna put 2 in each of these spots, and we'll get an answer. 2 to the third power is 8, so this would be negative 8/3 plus, this would be, this ends up being 4, so half of 4 is 2, and then plus 8. So this is 10 minus 8/3, or if I do a common denominator, 10 would be like 30 over 3, minus 8 over 3. 22 over 3. Okay, that's what we get on the left side. So that's what we get when we plug 2 in. Now, the really nice thing is when you're plugging 0 in, your antiderivative will always have an x on the end of it. Like it will never have a constant number, right? Your antiderivative will always be something like x is attached to every single term. You'll never have like a plus c on the end of it. So when I'm plugging zeros in, like I plug 0 in here, plug 0 in here, plug 0 in here, your 0 will always end up being 0. Okay, you'll find that going forward. So 22 over 3 minus 0 is just going to be 22 over 3, or 7 1/3, which is 7.3 repeating. That is the exact actual area underneath of this curve. So yesterday, for the homework assignment, when we estimated this guy right here, the actual area is 7.3 repeating. Now, notice that 7.3 repeating is not exactly in between these two, right? I think 7.25 is exactly in between those two, so it's not exactly in between the estimates that we found. It's just going to be somewhere in between that. Okay, not the exact middle.
Where did you do that?
This was the homework assignment that we did yesterday. I gave you a paper, I think, on whatever day, Monday, before you left, and I said this is what we're doing tomorrow. So that's number 8. So we have just found the exact area for the estimate that we calculated in number 8. Make sense? Mm-hmm. Yeah, and we do that by doing an antiderivative. Okay, so go down here to this bottom, and I just skipped through like a whole bunch of stuff, but it just shows you like how this stuff works. Okay, so it says, note the definite interval can be used to find the area of a region. So let's pick apart this. This is your function. Function dx is the variable that you're taking the antiderivative with respect to. So I'm going to say with respect to x. And then b and a are going to be left and right endpoints. So this is going to be your left endpoint, and b is going to be your right endpoint. Okay, and what I mean by that is like above, when we had the curve thing, like it was curving like this, we were finding the area from 0 to 2. So that means this is my right endpoint and this is my left endpoint. Okay, so A is 0, B is 2. Make sense? Ish. In a nutshell, that's how that works, right? Okay. Good? Can I go on? Maybe? Sure? Okay, let's go to the back side. Let's do a couple weird things, and then we will jump to, actually, you know what?
I think we should be done.
We're going to wait on the example 1 and 2 on the back side, so we'll just stop at the first example, but let's do like one of these together real quick. Okie dokie. We'll do, I don't know, which one's a hard one?
I don't know.
Like, you might get tripped up on number 1, actually.
Okay.
Maybe. I don't know. It's really not hard. What's the antiderivative of this number right here?
8x.
8x, right? Okay. And then you would take and plug 6 in, and then you'd subtract what you get when you plug 2 in. Okay, so maybe that's not that hard. So let's pick a harder one. Let's do like 6. Should we do 6? Sure.
Sure.
All right, what's the antiderivative of 2x squared?
What?
2x squared. Antiderivative.
1/3.
1/3 times 2, so
2 cubed.
2/3 x cubed. Yeah?
Huh.
It's a third times 2, so 2/3
Where is the 6?
x cubed. Oh, this is the one that I just gave to you.
Okay, sorry. I have like 8 papers.
Sorry.
That's fine.
Okay, so 2/3 x cubed. And then what's the antiderivative of 3? 3x. And now I'm going to use this notation again. So we've taken the antiderivative, but we haven't plugged our numbers in yet, right? Which number do you plug in first?
-2.
No.
1.
1. You plug in the top number, the upper number first.
Whatever.
Okay. So we're gonna plug 1 in. Okay, and when I plug 1 in, 1 goes here, 1 goes here. So 1 cubed is 1. So that would be 2/3 plus 3. And 3 as a common denominator would be 9/3, right? So that whole thing is
11/3.
11/3. Beautiful. Minus, let me go in and erase some things. So now I'm going to plug in -2. Ooh, I know that this is going to be -6.
-8.
-8 times 2/3 is -16/3. -6 will be -18/3. Yeah?
Sure.
-16/3 minus 18/3 is 34/3.
What about plus?
Yeah.
Wouldn't it be just
Minus
2?
negative
2/3.
No, this is not plus. This is just like -16 minus
Oh.
18/3, right? That was me rewriting the negative.
Oh, okay.
Yeah. So they're both negatives.
34.
So -34/3, okay? -34/3. Now I will have a double negative, right? Because you're doing minus, so this guy minus this guy, right? When I plugged 1 in, I got 11/3. When I plugged 2 in, -2 in, I got -34/3. So I do minus a negative, which
45.
actually means plus. So 45/3, which is?
I don't know, like 12,
No.
14, 16.
No. Think about
I don't know.
time. 45 minutes. If you divide that by 3, it is 3 intervals of 15. Yeah, 15 minutes. 15 times 3 is 45 minutes. I don't know. Good heavens. 15.
What did you say?
I don't know.
At
I think she
first
said
was
12.
Like 8,
8,
12,
12. I don't know.
16.
Something. So the area underneath of this curve from -2 to 1 would be 15. Yeah? Okay, let's look at what's going on down here.
I don't really know what's going on.
This one, it says, you see the magical words, do not evaluate the integral. You're just setting one up. Okay? So this function is a horizontal line. It's a straight line all the way across. We do the interval from what to what? Left end point to right end point.
0.
0 to 4. So 0 to 4 of the function is
5.
called 5
dx.
dx. That's all. Do not evaluate the integral. That's all.
Okay.
Okay? These aren't too bad. Just getting you used to that. Okay, good?
So what do I do with the next one?
All right, next section.
Oh, what?
Should we do 11, 12, 13, 14? We'll do one of those. And then we won't do any of the backside stuff yet. Okay?
What about that?
Let's do like 14. Okay? We're finding the area from 0 to 2 of 3x plus 4. What does 3x plus 4 look like?
A line.
It's a line. Y equals 3x plus 4. I always think about it in terms of that. Okay? So let's graph 3x plus 4. So I start at 4 and go up 3 over 1, 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 and I make my line. Boop, ba-doop, ba-doo. And we're only finding the area from 0 to 2. So that is from here to here. Just that little area right there. Okay? And then it says rather than doing the antiderivative, they want me to use geometry to figure it out.
That's not
No.
that hard. Okay, so
That's not that hard. So we have 2 pieces, right?
Yeah.
Yeah, do you chunk it off here? So this is a rectangle, and this rectangle is a 2 by 4, so it is 8. Okay? Then this is a triangle, and it is a 2 by 6.
So it's 6.
So 2 times 6 is 12, divided by 2 is 6, yeah? Because a triangle is 1/2 base times height. So
14.
the final area is 14. Yeah. Okay, good? Happy with that?
Yeah.
Sure. Okay, just work on those.
Okay.
We'll answer any questions tomorrow, and then we'll go over backside stuff.
Okay.
Yeah. Okay. Very good. Bye, people in the video.